than you'd see from this document, but nevertheless, it's a very large amount of energy. We know that Western industrial agriculture is very, very dependent on oil. And you can see this in what happened last year with the spike in the oil prices. You also saw a spike in the price of corn, wheat and other grains. And this graph comes from that same study that's just come out. So what about oil? Oil is really the most essential energy source in our society at the moment. And any decrease in the amount of oil available is going to cause huge economic problems because, as I explained to you, it simply means less happening in our economy. Well, there are a number of indicators that the oil supply is about to decrease. It's not just one or two or three ways of looking at this. In about 4 different ways, if you look at it, they are all telling you the same story. You can either do what's called mega projects analysis. And this is where you look at current fields and the rate at which production from those current fields is declining. And you look at the fields that they've announced are going to be brought online. In other words, companies, they explore, they discover, they then find a place and they decide, okay, we're going to develop this field and bring it online. It takes them at least 6 years to do that. So you can actually look at what's been announced out there as going to be brought online and into which they'll be investing billions of dollars. And you can look at the projections they have for production and put those against the projections we have for decline in the existing fields, and you can see what the total is going to be. And when you do that, it looks like, in a best case analysis, the peak of energy production from oil will be in 2011. Now, for an oil-consuming nation like Australia, that's actually not very important. What's important to us is how much oil we can buy on the world market. And the problem is that the oil-producing nations, the ones, the exporters, are using more and more of their oil themselves, and they're exporting less and less, because all of the money they've been earning until recently has been driving their own internal economic growth, and as well as they mostly have very rapidly expanding populations. So there's less and less oil available on the export market, and that's what drove up prices last year until the system collapsed. And I'll show you that in a moment too. There's also, we can look at computer models of world oil production, which were predicting a peak around 2007, and we can simply do the examination of reserves and predictions from that. Here's the mega projects analysis, and it's showing a decline in about 2011. Now, I have to say that the scenario since then has become worse because, as I said, this is mainly based on projections of what's going to be coming on in the next few years. The recent economic collapse has led to the cancelling of a lot of investment in new production, and so we're now expecting a much more rapid decline. This is from a paper published by Professor Kjell Aleklett, who's the head of what he calls the Global Energy Systems Group in Uppsala University. He's also the head of the Association for the Study of Peak Oil and Gas International. And they've recently started publishing this. It comes from a paper which is in Press in Energy Policy, and it's basically showing you oil production recently. It shows you that since about 2004, we've been on a plateau in production, despite the ever-increasing price of oil over that time and the increasing demand. So despite this huge economic incentive, we've been unable to grow our production in the last 5 years. And that's because we're at the limits of the system. This is the world oil export prediction showing you how much would be on the market, and we can see, and this is integrating data from about 20 exporting nations, the 20 biggest ones, and we see that there was a prediction for a peak of exportation in 2006 and then a rather huge decline by 2020, well over 30%, maybe 40% in the availability of oil on the world market, which would have huge consequences for us. And this is a bit out of date now because, of course, they're dramatically reducing production to try and keep the oil price up, and also consumption has dropped quite a bit because of the economic crisis. But we see that those predictions were reflected by real-world behaviour because we did seem to have a peak in exports in about 2006. And this is Australia's situation. Our internal domestic oil production peaked in 2000, and we've been pretty much on a downhill trend since then. So actually, from Australia's point of view, by 2020, we're looking at a very serious situation. We'll have virtually no internal production, and we'll be competing for a much diminished amount of oil on the world export market. So we are heading quite rapidly into a crisis. Now I'd like to talk a little bit about the person who's thought of as the godfather of the peak oil idea. This is M. Kim Hubbert. He was a geophysicist, worked for Shell, worked for the US Geological Survey. He was a bit of a genius, and his colleagues used to say that he's a bastard, but at least he's our bastard. He was a bit of an irascible, not very pleasant man to know. He didn't tolerate fools lightly. But his great insight was that the use of any non-renewable resource tends to follow a particular curve. We see a kind of exponential growth up to which then levels off to a peak, and then pretty much a mirror image in terms of the decline down the other side. On this side, we're rapidly expanding our use of the resource, and the resource is fairly easy to extract. We then reach the maximum rate of extraction, and I have to emphasize this is a rate of extraction graph, at a particular point, and then as the remains of the resource get harder and harder to extract, our rate of extraction declines. He's famous primarily for having predicted the peak in US oil production. Now, maybe there are people in this audience who actually do appreciate this, but we think of Saudi Arabia as being the king of oil, but back in the 1970s, it was the United States. It had twice the production of Saudi Arabia. And of course, it was this cheap and very abundant oil that led to the growth of the American economy. And what he basically did in his analysis was he assumed a logarithmic progression of oil use, and then he looked at the total resource base that was estimated, and he simply put those two together, and you come up with a curve for the way or the rate at which oil will be extracted. And what's interesting from this particular graph, which is what basically shows his prediction that oil would peak in about 1970 in the US and then go into decline, which turned out to be correct, is that he draws two curves here depending on the actual ultimate amount that can be extracted. Here we see 150 billion barrels, and here we see 200 billion barrels. What you notice here is that it doesn't actually matter very much. You can make huge increases in the amount of oil, but it doesn't shift the peak and then decline very far. So the actual peak date is quite insensitive to the amount of oil that is there, and that's due to the exponential nature of the growth on this phase. There's actually another way of doing Hubbert analysis, and this isn't, and I really like this form of analysis. It's called Hubbert linearization analysis. He did actually invent this himself, but he never used it very much, and it's been popularized more by a colleague of his called Ken DeFace, who was a professor of geology at Princeton Uni. And this is a method called Hubbert linearization. And what you do is, rather than looking at production versus time, which gives you your characteristic peak, what you actually do is you look at the annual percentage production. So you look at the production in any one year over the total production, and then the total production to date, and then you divide that here by the total production to date. And this gives you a linear characteristic here, which enables you to actually project the total amount that will be produced. So here you're actually able to estimate the total production from what's going to be produced. And anyway, I'm running out of time, so I'm not going to be able to go much into it. But if you then plot the world's production, you see it falling into this straight line, and we can predict that about now is when we're halfway through, and that's the moment for peak.